Hey, welcome everybody to our January 2023 Kubernetes Atlanta meetup. It's been a couple months, but happy to be back, kick off the first meetup of the new year. We have some really great speakers today with some awesome content. As usual, we're going to begin with a little bit of housekeeping. Do a call out for anybody that is currently hiring. If you'll post in the chat what company you're with, what positions you're hiring for, and how people can get in contact with you. We'll collect those towards the end of the meetup and put those in our meetup notes so anybody that's looking can view those and figure out how to get in contact for those types of roles. So again, please post that in the webinar chat and make sure you include contact information for how folks can get a hold of you. While folks are doing that, we'll go ahead and jump into our normal This Month in Kubernetes news section. So we had a lot that happened between last meetup and this meetup, but we're going to kind of keep things focused on what's happening now. So we're currently in the 1.27 release cycle, and the next major deadline is for PRR reviews. And if you're like me and you forget things and forgot what PRR is, that's the Production Readiness Review. This is a new piece that builds on top of the KEP, or Kubernetes Enhancement Proposal concept in the project, that makes sure that new enhancements to the Kubernetes project are reviewed for scalability, resiliency, and things of that nature. It's just a more fine filter to make sure we're getting mature features introduced into the project in a safe way. So if you're contributing upstream, keep an eye on that. Another thing to call out is we did have some recent fixed releases for the 4 latest Kubernetes releases, 1.26, 25, 24, and 23. Special call out here is that Kubernetes version 1.22 is end of life, so it is not receiving these security updates. And this fixed release was actually related to some Golang security issues that were like known problems. So this was kind of a bump in like the Golang versions supported in the upstream project. So please upgrade. Again, getting into promotions, deprecations, CVEs, and things of that nature. If you see an NA here, that does not mean that there were no promotions or that there were no CVEs. It just means that there's none that we felt strong enough to call out and talk about here today. But moving into deprecations here, there's work going on to actually remove all of the code for the existing pod security policy feature set of the Kubernetes project. So as of Kubernetes 1.25, all of the features are turned off, I believe, but the code still was hanging around in the code base. So this is some work that basically removes it from everywhere other than client Go and one other place, I think. But yeah, if you're using pod security policies and relying on them heavily, please check out some of the new replacement features for that. Reach out if you have any questions. And then also another deprecation here is the legacy leader elections methodology that revolved around using config maps and secrets for coordination of leader elections. That will be going away in the near future. The lease API that replaces that has been around for quite some time now. So if you have any legacy controllers or Kubernetes tooling that's making use of the config maps and secrets, look into moving that over to the lease API. Getting into PRs of note, auto-scaling v2 API is now the preferred version of the API that's out there. So interacting with like HPAs and stuff like that, we'll use that now. And the V1 of the API will be moving towards deprecation. So if you're using the like horizontal pod autoscaler configurations, take a look into that. You've probably been getting some nasty nagging warnings from kubectl and things like that if you've interacted with those lately. And then moving into some community news, this is a section where we just talk about interesting articles, tools, and things of that nature that caught our eye and we wanted to share with the community here. The first one up is something called Troubleshoot, which Ross, I think you shared this with me a while back. But I thought it was pretty cool. This is a kubectl plugin, actually a kind of a couple of them, I think, that supports a number of different features around like pre-flight checks going into Kubernetes cluster upgrades and maintenance scenarios, but also being able to grab a sort of holistic support bundle of different diagnostic information about your Kubernetes clusters. If you're an old school Unix guy like me, you know, you might remember like snaps from IBM or AIX or Explorers, Sun Explorers from Solaris and things like that. But gets a lot of information from your Kubernetes cluster that may be helpful if you work with an enterprise vendor and you're opening a support ticket or something like that, or you have a dedicated platform team, information to be able to give them about a sort of snapshot in time of what's going on in the cluster. It's pretty cool. And then somebody that I really love pretty much everything they post here, but Daniel Mangum is working in like the cross-plane project and whatnot. This is the first part in a series he's doing that is the Kubernetes API Server Adventure series. And this particular one, he wants to deep dive on particular parts of the Kubernetes API server from a functional code perspective of how things work under the covers. And the first part in the series is covering the storage interface, which for a lot of people we associate with like etcd as the backend storage for the Kubernetes API server. But this breaks down all of the nitty-gritty details of how that works from a code base and what that interface really looks like from a logical and functional standpoint. And then some really interesting things you can do with like mocking a client to talk directly to the storage interface and things of that nature. So if you're curious about Kubernetes internals, this is a great article to dive into. Really looking forward to what else Dan does in this series. Another great thing from our community, Tim Hawken always drops these little tidbits of information. He's a self-proclaimed like visual learning person, as am I. So he focused on the concept of Kubernetes pod probes. So if you think like startup probes, liveness probes, readiness probes, things of that nature, he broke it down from a kind of flexible point of looking at some of the things of how it's implemented in the code, but also trying to visualize some of that in a visual flow diagram here. So this is pretty important if you've never like really grasped like the startup probe, what happens when it hands off to a liveness probe, when it hands off to a readiness probe and things of that nature. This is just really concise, really good read, just a few slides, but super good information to break down some seemingly simple topics that get overlooked a lot and some people can be hard to understand. So this is another fun one here, K8s failure stories. So this is a site, and if I remember here, it is K8s.af is the site. And this is basically a site of Kubernetes failure stories, which I think is awesome as somebody that's, managed Kubernetes platforms for a while now. Being able to have that kind of solidarity and validation that like you're not the only person that ever has these problems with your platform. These are just fun stories to go through, and these are from companies of all sizes, all different types of teams that could be, operational based, SRE based, software engineer based, everything in between. These are just really, really fun to read. Some people are very creative writers, and they can take something that was probably a very bad day to them and make it learning material for the rest of us. So thank you to everybody that's contributed to this. Also, please go check it out. And then this was an interesting one that caught my eye today, both in name and function. So this is called Clusterpedia, the Encyclopedia of Kubernetes Clusters. And this is a really interesting project that basically it has, see if I get down here to the architecture piece. It has what looks like a kind of complex architecture at first, but it basically, from my understanding, breaks down into, you have a sort of agent that gets installed on all of your Kubernetes clusters, and then you have some components that aggregate all of that information from those agents into a concise API endpoint on like an administrative cluster that you might have. And then you basically have a storage component that stores all of that information And then you can kind of interact with it with kubectl, or you know, with some of the like raw functionality of kubectl, and it gives you a different a slightly different interaction that feels very familiar. So it basically adds in this -- cluster filter. So if you think in traditional terms, you can do a kubectl get deployments -a, you know, you get the deployments across an entire cluster. But now you can get that across multiple clusters because all of that information is aggregated into a central place. You can still filter by cluster, but you can also do fun things like label selectors across resources across your entire fleet of clusters. So pretty interesting project. Look forward to seeing what comes of this and how it goes. They have some really great examples here of what input output looks like for some of these things, and some scenarios of how you might use it for various things. But really interesting thing. I've hit this kind of problem at multiple places I've worked, where like once you start to build clusters and you go from like 10 clusters, 50, hundreds, thousands of clusters, being able to query all of them and get information in a concise manner can be pretty difficult. So very interesting. All right, and that does it for this month in Kubernetes news section. So we'll get into the normal meat of the meetup. And before we do that, real quick, I do want to throw a shout out there to Calendly, who is our sponsor for this month's meetup with the Zoom and everything else. So thank you very much to the folks at Calendly for providing us the means to continue to put on these meetups. I'm going to skip reading the hiring stuff right now just because I'm flying solo today, so I haven't been able to look through the chat yet on that. But jumping in, we have a couple of speakers from Loft Labs. We have Rich Burroughs, staff developer advocate, and Carl Montanari. Hopefully I didn't murder your last name there, Carl. Senior software engineer, and they are going to talk to us about virtual Kubernetes clusters, tips and tricks. So that being said, Rich, Carl, please take it away.
Hey, thank you so much. Let me just share the slides real quick here. So for you all watching, we're going to be kind of bouncing back and forth. I'm going to be presenting slides, and Carl is sort of the mad genius who has some demos. And so we're going to be handing the screen sharing back and forth. So if you find you can't see something, please do let us know. Yeah, so we're talking today about virtual Kubernetes clusters, tips and tricks. About us, I am creator and host of the kubectl podcast, where I interview folks from the Kubernetes community. I worked in operations for 20 some years, and I have seen some things.
And I'm Carl. Going to be doing the demo here with Rich, developer here at Loft. Sometimes I write good software. That's kind of the exception, not the rule. And generally, I believe that computers were a mistake, but it's also fun to say evergreen things like that. So.
So what we're going to cover tonight, we're going to talk about Kubernetes multi-tenancy challenges, what are virtual clusters, and some vCluster tips and tricks, which is the main part of the presentation. So first, the why and what of virtual clusters. Kubernetes multi-tenancy is hard, y'all. There mainly been two Kubernetes multi-tenancy models. Namespace-based isolation and what I'm going to call cluster-based isolation. With namespace-based isolation, tenants are restricted to one or more namespaces using things like RBAC and network policies. Some of the pros of this, it cuts down on cluster sprawl, which is really big. You tend to have less wasted resources because you're packing more workloads in. Some of the cons, users can't manage global objects like CRDs. And this is something that you don't necessarily want users doing in production, but in a dev environment, you're going to want to be able to do that probably. Users may need multiple namespaces. And so if you're thinking that you're locking people down to namespaces, maybe they have multiple services that run in different namespaces that need to talk to each other. And then you're making network policy exceptions and all of that. And so really, the bottom line is that these environments can get very, very complex when you've got a bunch of people, running different things. With cluster-based isolation, everybody gets their own dedicated cluster. Some of the pros here, a lot better isolation, less complexity in each cluster because there's, maybe only a few services running in each one. Some of the cons, it's difficult to manage a whole bunch of clusters, and I expect that a bunch of you know that. You are maybe going to have more wasted resources, just like in the old days, when we used to run, a specific app on a specific host. It's kind of the same thing because you're not packing those workloads in. And cost can be a big problem here. And one other thing I like to call out, there was this really great talk from Holly Cummins at KubeCon a few years ago, and she used this term, she called them zombie clusters, which are clusters that have workloads running and maybe even, nobody's actually using them. Maybe nobody even knows that those workloads are running at all, and that takes up power, and power consumption is a big problem when it comes to the environment. So if you get a chance and you're interested in this topic, I definitely recommend looking this talk up on YouTube. So, okay, which are you going to choose, namespaces or clusters? There's another option now, these virtual Kubernetes clusters. A virtual cluster runs inside of another host cluster, but it appears to the user as if it's a standalone dedicated cluster. So we're going to be talking today about vCluster, which I guess some of you may have heard of. I was told beforehand by Joe that Lee Capilli did a presentation at one of the earlier meetups last year. Lee is awesome, super happy to hear about that. And I know a lot of people have been paying attention to vCluster, but it is an open source project that was launched in April of 2021. It's currently the most popular implementation of virtual clusters. I think there's not even much of a competition there. It's become really, really popular. And it's a certified Kubernetes distribution, so it passes the CNCF's conformance tests. And it's really fast and easy to use. So how does vCluster work? The virtual cluster runs inside a namespace on a host cluster. So that's one way to think of the virtual cluster, is that it's literally just like a control plane inside a namespace. And that could be a host cluster that's got a whole bunch of namespaces. It could be your own local Docker desktop cluster, whatever. The vCluster pod contains a Kubernetes API server and some other tools. And the virtual cluster saves its state in a database. That's SQLite by default, but you could point it at etcd or Postgres. There's a few options. And then the vCluster client itself is a really small Go binary. It's very fast. So let's take a look at the kind of basic overall architecture here. So here's my underlying host cluster. As the admin, I'm going to control the context of that cluster, and I connect to its API server. And it's got all of those normal things running in the control plane. Now I can make a namespace here and put a vCluster inside of it. So we've got a vCluster pod, and that has some things in it. It's got an API server and that data store that we talked about, the SQLite data store. It has a controller manager, and it has this thing called the vCluster syncer, and we'll talk more about what that does. Now, as the tenant, I'm going to connect to the API server of the virtual cluster, and I control the context of it. And so I can make a namespace in there. I can create deployments, pods, all these things that I would normally do in a cluster. Now, if you look on that orange line for the vCluster, you will see that there is something missing, and that is the scheduler. So that's where this vCluster syncer comes into play. So when I create a pod in the virtual cluster, the syncer tells the underlying cluster scheduler to schedule that, and it gets scheduled down there. And there is this bidirectional communication, to make sure that the state is current. So I'm going to turn it over now to Carl, and he is going to show you how this works.
In theory. We'll see if we can make this happen. So quick disclaimer, real quick. So the demo is actually live. It's just scripted, so I don't have to make typos and embarrass myself in front of everybody. But this is real stuff happening against a real cluster. And so just to start, this is just a simple K3s cluster managed by K3D, just running in Docker Desktop on my Mac. So we've got some nodes, multi-node just for funsies, really no reason for the demo. And we can check out some pods. There's core DNS, there's nothing else running. Pretty straightforward. So just to kind of level set. So now we can get into checking out actually creating a vCluster, obviously the whole point of all of this, right? So as Rich mentioned, vCluster CTL, vCluster CLI, vCluster, whatever you want to call it, the command line tool here, small Go binary, super simple. It's got some commands as you'd expect, create being one of them. And so in this example, we can just say, hey, let's create a vCluster, call it my vCluster, create a namespace, we give the namespace. We're saying connect false because by default, vCluster is going to want to automatically connect to that virtual cluster that it's created. And I don't want to do that for the demo because it'll do some port forwarding magic. And then also the last thing here is we're passing some values, and this is just to set up an ingress so that I can go ahead and connect to the API server that's actually running. So you can see I've just kind of been advancing this along here. So we got some output, create a namespace, create some vCluster, awesome. We can also use a vCluster CLI to go ahead and list vClusters, as you might imagine. In this case, we can see, hey, pod initializing, probably a pretty good start. This is actually happening real time. The only demo magic here is I pre-seeded the vCluster image onto the nodes, so we don't have to wait for my horrible internet to download them. But otherwise, you can see, less than half a minute usually, we have a functional Kubernetes cluster running. And then here we'll just check, make sure the ingress is up so I can actually go ahead and connect to it. Without that, we're not getting very far. We'll also use vCluster CLI once again, in this case to actually connect to the vCluster API server. So obviously we give it the name of the vCluster we want to connect to. Again, I'm saying update current false. This doesn't update my kubeconfig. It's just going to pop out of kubeconfig, as you can see in the example here. The last little bit is just so that we can actually update the URL for the API server to something that I can actually get to, hiding behind the NAT that K3D is managing, or the port forwarding, I should say. If you've seen a kubeconfig, which probably everybody here has, this should look pretty straightforward. It's pre-populated, just a pretty standard kubeconfig, so nothing too exciting there. But at this point, we have a functional vCluster running, full-blown Kubernetes API server, so we can go ahead and interact with it just like you would expect with anything else. So we'll just set the kubeconfig to this new kubeconfig that was just generated by vCluster Connect, get nodes. Sure enough, we can see one of these nodes that came from that real cluster that we were working with. There's only a single one synced here because by default, vCluster is only going to sync nodes that have workloads running on them into the virtual cluster. This is configurable, and we'll talk a little bit about that later, but that's why we just see the one. And then once again, get pods, great, brand new, core DNS, nothing very exciting. And we can kind of just keep going. At this point, you kind of get the idea. We can interact with it like a normal vCluster. So we'll create an Nginx namespace, create a deployment with some replicas, just 2 replicas just for funsies, just so we have something to look at, really no reason. And then again, great, we can fetch the pods. Also preceded this image on that. The Nginx image is very big, but we can see that we've got some Nginx pods running as expected. Now here's where it kind of gets a little more interesting. So in the last couple of kubectl commands here that we've ran, we've been setting the kubeconfig to that kubeconfig to connect to the virtual cluster. Now we're back in the host cluster, the parent cluster, the underlying cluster, whatever you want to say. I don't think there's a one true correct term for what that is, but hopefully you get my drift. And we can see a couple interesting things here. First of all, we see the actual my vCluster pods running. So this is a stateful set. It's got 2 pods in it. This is or 2 containers in the pod. This is that API server, which by default is K3s, which we'll talk more about that in a minute. And then the second magic, where the magic happens, is the syncer pod or container. So that's why there's two containers in that pod. And then this is what kind of gets interesting. All of the workloads that get deployed into the virtual cluster, they're actually getting scheduled and ran in the host cluster, right? Because the virtual cluster is virtual, it has no real nodes where it can actually run these workloads. So what happens is when the syncer syncs these workloads up into the host cluster, or up or down, or however your perspective is, we do some namespace translation or name translation on these pods. And then that way we can have multiple vClusters in the same namespace in the host cluster. Inside of all of those vClusters, we can have an Nginx namespace, and they can all have pods named exactly the same. And because of this name translation, we get the uniqueness that we need to retain. So here we've got Nginx, this first part, obviously aligning with what we saw when we were looking at the pods in the vCluster itself. And then we add a little separator, the namespace that it's running on. So again, that was Nginx namespace that we created. And then the separator again, and then the name of the vCluster. And obviously, if this gets too long, we truncate it and hash it up and all that kind of fun stuff. But that's the basics of vCluster. Once you've got one spun up, you know, it's a real Kubernetes cluster, so we're doing real Kubernetes things. Yeah, so back to you, Rich.
Cool. Thank you, Carl. So now we're going to get into the tips and tricks. And, you know, we were chatting with Joe a little bit before the session started, and kind of where this talk idea came from for me was the fact that, you know, vCluster, like I said, it came out in April of 2021. Since then, we've added a lot of really cool new features onto it. And I don't know that we've been super great at publicizing all of those. And so there's a lot of things that, you know, are in vCluster that you might not be aware of if you haven't looked at it recently. So that's kind of the idea here, is to sort of shout out some of these things that folks might not know about. So the first one is distros. So the distro is the version of Kubernetes installed inside the virtual cluster itself. So the default is K8s. And when we started off, this was a sort of experiment that was kind of a continuation of Darren Shepard had been experimenting along these lines of like having some sort of virtual Kubernetes cluster with K8s. And so we started there. And then as time went on, we had people start to come to us. And the first person asked us if we could support K0s as well, because they wanted to use that. And we were like, sure. And then we were on a stream with the AWS folks. They do this stream called Containers from the Couch. And we were talking about vCluster on there. And within a few hours, we had a PR from Justin Garrison that added EKS. So it's the actual Amazon, you know, Kubernetes distribution that they use for EKS. You can use that as well. And then there's what we call vanilla Kubernetes, which is a more standard Kubernetes distribution that has etcd and all of that stuff. Tip number 2, creating virtual clusters. So there are 3 ways to do this. You can use the vcluster create command like Carl did in the demo. You can use the vcluster Helm chart. And there is also a cluster API provider as of, I think, just a couple months ago. So let's start off with the Helm install, because you saw the command line version, the vcluster create. The Helm install is actually used by vcluster create. So if you might have noticed in the output, if you were looking closely, that there's actually a moment there where it runs a Helm command to create the virtual cluster. So the Helm install is really solid. Definitely something you can rely on. It's really great, you know, if you're doing some sort of GitOps or automated workflow where you don't want that CLI interaction. This is the vCluster repo, and we have a charts directory inside of there. And then there is a specific directory for each one of these distros that I was talking about. And so this is the K8s one. And there's a values file inside of here, which is a really useful thing to look at. It shows you the different things that you can potentially override, you know, if you're installing with Helm. And a lot of those things correspond directly to the different command line flags that you'd have if you were doing vCluster create. The cluster API provider, like I said, it's pretty new. If you're not familiar with it, cluster API is used to provision Kubernetes clusters and manage their lifecycle. To use our provider, you need the cluster CTL tool that the cluster API provider folks built. And what this does is it creates virtual clusters in the local cluster. So whatever cluster you are sending the commands to, that's where the virtual clusters will get created. This is the repo for the cluster API provider. So feel free to check that out on GitHub if you would like to use it. And this is just an example from the docs of like a little, you know, shell script that you could run that would create a vCluster using the provider. And that's right there in the README on the GitHub site. Number 3, exposing a vCluster. So we've got this virtual cluster and we want to connect to it somehow. The different ways we can do that, there's port forwarding, and there's, like Carl said, by default, if you run vcluster create, it'll try to port forward you to the virtual cluster. There also is a vcluster connect command that you can run to do that same thing. You can also use a node port, and if you create a local cluster, by default, vcluster will set it up to be a node port so that you don't have to do the port forwarding. So if you're using like Docker Desktop or Minikube or something like that, vcluster will detect that and just use the node port instead. But you can also use that for a remote cluster. You could use a load balancer, and there's a --expose flag for that. And you can use an ingress, and that could be in the virtual cluster, or it could be an ingress in the host cluster that gets shared into the virtual cluster. Tip number 4, this is maybe more of the tricks inception. So you can run a virtual cluster inside a virtual cluster, and in fact, you can do multiple levels of that. There was a really funny talk at Cloud Native Rejects where Mike Tugeron from Adobe, I think at one point he had like 18 like levels of nesting going on with his virtual clusters. Even if you don't have a great use case for this, it's just a fun thing to do, to just launch one of these virtual clusters and make a cluster inside of it. So I'm gonna hand this back to Carl now, and he is gonna show you some stuff.
Cool. Oh God, sharing screen. Computers are hard, y'all. All right. Yes, so vClusters, inception. Once again, we'll just level set. We're looking at the lovely nodes of, oh God, Zoom is talking to me here. Oh God, you got to be smarter than the computer. All right, sharing, it's all good. Okay.
Yep.
Cool. So once again, just kind of level set some nodes. Cool, great, good. This looks familiar. But what happens if we look at the pods that are running in this cluster? You might notice some interesting things. The first thing that might stick out is that, wow, those are some really long names for pods. And if you kind of dive in a little bit further, you might notice that those names for pods happen to line up kind of weirdly, eerily similar to what we saw in the previous demo. So the real trick here is that, just like the last slide, inception, the last vCluster we created was actually created inside of this vCluster 1. And so we were doing the inception ourselves. And so you can see, here's the vCluster 1. So the same as what we saw in the previous example, where we saw, my vCluster -0, the pods that the stateful set created for us. And then here's the actual my vCluster 0, which is the one that we created in the previous example. Because this is actually running inside of vCluster 1, just like we saw with the translation for the name on the Nginx stuff, we can see that we have the same thing going on here. So this is running in the my vCluster namespace inside of vCluster 1, inside of the vCluster 1 namespace. And what basically happens as we kind of keep syncing these pods upwards, 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 or downwards, 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 whatever your perspective, into the real cluster, we'll keep translating those names because we have to, ensure that we can maintain uniqueness of the names and stuff. So that's what's happening here when we look at these Nginx names. We see that the first part, remains exactly the same as what we saw before. And then we're adding, and this is already getting cut off and truncated and hashed so that we can, fit in the character limit. But this would be saying, my vCluster, which is the namespace that the vCluster is running in, and then dash vCluster X if it weren't getting concatenated. So then we can say, okay, great. Here we're blowing a little bit of the secret magic of the demo. So using demo magic's shell script thing here, we were actually kind of lying to you with which kubeconfig or which kube context we were operating in the previous example, and that's how we kind of made it look a little, Hollywood movie going on here. But if we access the kubeconfig for vCluster 1, which is from the perspective of the previous demo, we can see, hey, this looks interesting. Here's the my vCluster that we created in the previous example. It's in the my vCluster namespace, and here's the pods that we created. So again, like Rich said, the vCluster inception thing, maybe not the greatest use case. I'm sure there's some use cases, but it is kind of neat. It's kind of an interesting way to kind of look at it and grok a little bit about what's going on with vCluster. One of the things that I think is probably absolutely my favorite thing, not probably, definitely my favorite thing about vCluster is, and I use it every day for doing dev work for Loft, is that once I nuke the vCluster, everything's going to be gone inside of that vCluster, right? Because all of those resources are going to get cleaned up. So here I just said, okay, great. Let's delete the vCluster using the vcluster.ctl again. I also delete the kubeconfig just to be tidy. And then we can say, hey, look, from vCluster1's perspective, what are my pods? Well, before I had, the Nginx pods, I had the vCluster itself, and then the core DNS running in the vCluster. And by the time I got around to hitting enter again, because I'm slow, all of that was already cleaned up, right? And now if we go again back up to the real cluster here, we can see all of those vCluster resources were nice and tidily cleaned up. So I know, like, we talk about vCluster a lot. It's like, oh man, it's really great. So you can do CRDs and yada yada yada, and obviously that's absolutely true. But it's also really, really nice that you're able to like super simply clean up all of these resources and start from scratch whenever you need to. And with that, back to Rich.
Awesome, thank you. All right, so tip number 5 is isolated mode. So this creates some additional isolation for the vCluster. When we started out, some of the use cases we were thinking of were like dev environments and CI/CD. But as time has gone on, people started using this thing for more serious workloads. And in fact, we've even seen people like using vCluster to build features in other products, like their own even commercial products. And so eventually there was a time where people, mentioned that they'd like more isolation than you get by default. And so you just can run vCluster create --isolate. It'll automatically create some objects for you. One of them is a pod security standard, a resource quota and a limit range, and a network policy if the CNI that you're using in the host cluster supports those. Now these things get created automatically with default values, but you can tweak those values like in the values.yaml file if you want. Number 6, applying manifests and charts. So users can apply Kubernetes manifests or Helm charts automatically when a vCluster is created. So the way that I think of this is like, take a dev environment, for example, it's one thing to have just a bare bones cluster provisioned, and it's another thing to have that be an environment that's actually useful to people. And there's probably a lot of like configuration and installation of things that needs to happen in between those 2 points. And so this is a way that you can do that without reaching for another tool outside of Kubernetes and vCluster. So you specify the manifests and the charts that you want to use in that values.yaml file. And you could apply, just random Kubernetes YAML. You can use public Helm charts and it'll download those, or you can even use private charts and you point at those as tarballs, like you point at those. Plugins were a really big addition that showed up last year. They're basically a way to change the behavior of vCluster syncer. So this is like the extensibility that's there. Plugins are written in Go, and they're very flexible. You can do all kinds of things, and we're actually going to show you an example in a little bit of one of those. And we made this vCluster SDK. It's a separate repo, but this is basically the helper for developing plugins. And we also have on GitHub this vCluster plugins repo. And this just has a couple of example plugins in it. There's one for using Cert Manager, and there's one for using Contour. But basically, a lot of the tasks you're going to want to use, you're probably going to want to do with a plugin would be things like sharing resources, in either direction, right? So like a resource you've created in a host cluster that you want to make available to all the virtual clusters, or maybe a resource in the virtual cluster that you want to exist in the host cluster as well. So either direction there, and you can write plugins to do those things. And back to Carl again with more demo stuff.
All right. Cool. So, yep, just like Rich said, plugins. So manifests. I got all caught up in the moment with the plugins, man. So we saw before, we mentioned that there's values for vCluster, of course. So this is just a snippet of a values file we're about to use to deploy another vCluster. Just using YQ to kind of grab just the manifest section. In this case, I'm just going to deploy regular Kubernetes resources, no Helm charts, but you could do the same as well. So like just take a quick look here. We've got a namespace, a secret, a deployment that we're going to talk about a little bit more here in a moment, and a service and an ingress. And this is all just exposed with like Etsy host entries, so I can get to it. So nothing too crazy there. This time, since we used vCluster CTL before to go ahead and deploy stuff, we'll switch it up and use Helm. Like Rich mentioned, you're always using Helm, whether you're a layer away from it or not is kind of the only difference. But in this case, we'll say, hey, my vCluster 2, namespace, create the namespace. This all looks and feels pretty familiar to everyone, I'm sure. Point out at the charts.loft.shell repo, of course, give it that values file we just looked at, get some lovely normal Helm output. Well, great, good. And then we can go ahead and take a look at the pods. Obviously, we're not gonna, we just want to kind of ignore vCluster CTL for now. So we'll just look directly at the pods. So sure enough, my vCluster 2, nothing too exciting here. We'll just kind of keep looking until this vCluster deployment is up and happy. So sure enough, see if my cool little demo script works. Nice. So the next thing we want to look at, because this whole init chart manifest thing, we expect, or we hope that we're getting this demo pod that we just saw in the manifest actually deployed. And sure enough, we can see container creating, and also, of course, the core DNS that we, love and expect in our vClusters here. So now we've got all these pods running, should be good, but we also want to just check to make sure, hey, we've got a service. Here's this demo service. I'll talk about this a little bit more in just a second. Again, check the ingress. Cool, there we go. We've got this demo ingress, and this is where we're just exposing this silly little demo pod that we just looked at. So what's this demo pod doing? It's running an image that I basically kind of ripped off from HashiCorp. They have like a HTTP echo image, and I just changed it just enough to put my name on it. No, I'm just kidding. I just changed it so that it's actually loading a thing that it echoes back to you from an environment variable. And so now that secret that we saw was mounted in that pod, and that's where we expect to be getting this thing that we're going to get curled back or get responded to us when we curl this thing. So race car, cool. I like palindromes. I like to go fast. Go team. Seems pretty good, right? So then we want to check and see where this mysterious race car word was coming from, right? So two things here. So one, we'll just get the deployments. We'll use YQ and some funny stuff to yoink that container that we care about out. But also another cool thing here is we can use vCluster CTL to connect. And then with the dash, we can just send a command directly into that vCluster. We don't have to pop out a kubeconfig. We don't have to update our current contacts. We don't have to do any of that. So this is just a handy thing. And also we didn't deploy the vCluster with vCluster CTL. We just deployed it with Helm. So we can still do that. So that's kind of nice. It's just a nice to have little quality of life thing here. And then, yeah, so hopefully momentarily, we'll see, there we go, some stuff from this container. And again, this is just that silly little echo M image. Okay, great, good. The args that we're passing to this little tiny thing is say, hey, I want you to echo the M called secret. And then sure enough, we have this environment called secret mounted from my secret. Pretty straightforward, very simple stuff, nothing too crazy here. And then once again, we can use this cool little vCluster connect thing, and we can go ahead and check the contents of the secret, my secret, that we deployed with that init manifest. And then, base64 decode, blah, 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 all the usual Kubernetes secret stuff. TacoCat. TacoCat is not equal to racecar. I'm not so good at spelling. There's probably typos all over this place, but I'm pretty sure those are not the same word. So the question now becomes, what gives, right? Where did this come from? And this leads us to the plugins. So Rich mentioned there's this vCluster SDK thing, and you could write your own plugins. Well, one of the things that we put in this manifest that we just deployed, or the values file for the vCluster we just deployed, was to enable this prefer parent resources plugin, which also I've made. So I know a thing or two about it. It's just a silly little kind of demo, but it kind of does what it says on the tin. We prefer a resource from the host cluster or the parent cluster to the resource that's deployed in the virtual cluster. So now we can say, okay, well, knowing what we know now, why don't we look at the same name secret? Oh, excuse me, I'm jumping ahead. This is what happens when you don't type it real time. We could just also check. You might have noticed earlier, this vCluster had 3 containers in the pod instead of the 2 that we've seen before. So API server, yep, check. Syncer, yep, check. That's the things you're always going to have. And then that third one is this prefer parent resources vCluster plugin that's actually running there in that same pod. And now that I'm not getting ahead of myself, we can look at the secrets that are living in the host cluster. So notice we're not doing the vCluster connect, yada, yada, yada. We're not using a kubeconfig. So this is the thing that's in the host cluster. The secret's called the same thing, my secret. It's at the same path, because of course it would have to be for the container thing to get mounted right and all of this fun stuff. And we see race car. So that's actually what was happening here. Even though there was a secret called yada, 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 whatever, the vCluster syncer made it such that when the pod got scheduled into the real cluster, it preferred to mount the config map, or in this case, the secret from the host cluster. So this is just kind of an example of what you can do. vCluster SDK, and you can really kind of sync whatever you want, wherever you want. So it can get a little, you can get complicated, or you can do simple things like this. It's really up to you. And then at the end of the day, this is just a tiny pod in running some Go code. And I know what logs to grep for because I wrote the thing. So we can just say, hey, this is where it found the secret that I would prefer. And off we go. Let's mount that instead. So yeah, that's the quick rundown on init manifests and plugins. Back to you,
Cool.
Rich.
Thank you, Carl. All right, got a few more tips. Number 8, pausing and resuming. So this was also added last year. It's a really quick way to suspend the workloads that are running in the virtual cluster while preserving the configuration. So there's a vCluster pause and a vCluster resume. And the way that the way the pausing works is it sets the replicas to 0. So for the stateful sets and the replica sets, it sets them to 0. It makes an annotation of how many replicas there were. And then when you resume, it changes it back to the previous value. So the nice thing about that is that the workloads go away, but everything else is still there. So all of your configuration is still there. The environment is just kind of ready to get started up with the workloads again. So while it's really fast to create and destroy these virtual clusters, there might be times where you just want to get rid of the workloads, but keep everything else. Number 9 is high availability. And this is, again, something that I would not have guessed was coming when we launched vCluster. I think that we were thinking of these as very ephemeral environments, these virtual clusters. I don't think that we ever thought that HA was going to be an issue, but again, it's like we've been really happy that so many people have been using the tool and have given us such great feedback. And again, people started these use cases that are much more production-like, and they wanted to have HA. So what this does is it creates multiple copies of the vCluster components to run on the different nodes. This works only with K3s and the vanilla Kubernetes distribution right now. You cannot use it with the K0s or EKS. And you specify the settings in the values.yaml file. So here's an example command line. You literally just say, the distro that you want to use, and then you point it at that values file. So I'm going to hand it back to Carl now, who's going to show you some stuff about HA.
It's the last one, I swear. Last time you have to deal with me, promise. All right. So, like Rich mentioned, this just, should not look super new. This is a values file that we could use to deploy a highly available vCluster. Some fairly obvious things like, hey, enable HA. That's a pretty straightforward one. But we also, in this case, are cranking up the replicas for basically all of the things. And also we're running, well, you don't see it here, but we're running the, or is it somewhere? I'm just blind. We're running the distro using K8s instead of K3s in this case, but you can do HA with K3s as well, like Rich mentioned. But we're just going to crank everything up to 3. And then the keen-eyed among you may notice some other things, but we'll come back to that in a quick moment and just take a look at an HA vCluster that's deployed. So some obvious stuff sticks out. etcd is really easy to see. Controller is really easy to see. API server syncer and core DNS. Great, cool. This looks HA, right? There's some common sense defaults in there about like affinity and things like that. There's some consistent things in there that you can, or there's some other things exposed with values that you can tweak. But you may have noticed also some other weird things happening here. Like, why is there a vCluster 1? Why is there a demo app? And why is there a my vCluster 2? So these don't necessarily pertain to HA, or they don't pertain to HA at all. But basically you've been bamboozled this whole demo, and everything that we've been doing in this demo has actually been in an HA cluster running in the original K3D cluster. So it's K3D, K3S cluster, or K3S cluster managed by K3D. But we deployed this vCluster in the first place in the demo setup. And inside of that, we created vCluster 1, the one that we bamboozled you with in the first place, where we created my vCluster in. And then we used this demo magic shell script magic to basically lie about which context we were kind of operating in. And so if we go ahead and now the lies are done, the deceit is gone, I'll be honest, at least the rest of this evening, then, it might reset. But if we look at vCluster list from the context of the actual cluster, we can see it only knows about vCluster 0, because of course that's the only one in the real cluster. And then if we look at just all the pods, we can see, hey, there's this Nginx ingress. We've been syncing, and all of these vClusters that we've interacted with, or almost all of them, have been exposed via Nginx ingress. We've seen that a couple times. This one Nginx controller was doing all of that magic, synced into all of the vClusters, including the one that was a vCluster and a vCluster and a vCluster that we started with. And you can see, the load balancer that K3D did, all the kind of magic stuff that's going on here. So nothing else to really show there, but just trying to make it a little fun and kind of joking around with the HA or the inception bits there. So that's it for me.
Cool. Thank you, Carl. We still like you, even though you are a huge liar.
That's how I got the job, so
Yeah. One last one here, one last big tip. So this is a relatively new thing. There's now a CRD sync plugin. Do you love the ideas of plugins, but you don't want to write Go? Great news. We built this thing so that you don't have to hopefully write some of the plugins at least. So we released this generic plugin for syncing CRDs a few months ago. It provides a way to enable use of any asterisk controller operator in the host cluster inside of a vCluster. So this is a way to share resources from the host cluster to the virtual one. You define mappings between the host and virtual clusters in YAML, and it likely won't work for 100% of controllers, hence the asterisk that we saw. So this is a pretty new feature and kind of bleeding edge. So it's possible you'll run into some cases where things don't work, but we would love to hear about that if that is the case. This is the GitHub repo for the CRD sync plugin, and this is yet another example, of what a plugin looks like if you want to develop some of your own and you're looking for examples. And that is it for the tips and tricks. So I want to leave you with some resources. A lot of these are things that we talked about already, but the big one is vcluster.com. So if you don't remember anything else, remember to just put the .com on the end. You'll find links there to the GitHub repo, to a bunch of other things. This is the GitHub repo, though. If you'd like to go to it directly, we're loft-sh. There's the vCluster SDK that we talked about. The vCluster plugins repo, where, again, it had a couple of example plugins. Also, I should mention that if you develop a plugin and you would like to share it with the community and have it included in that repo, please do hit us up, like open an issue. The cluster API provider, and that generic CRD sync plugin that we were just talking about. And then Carl has made available the repo from his demos today. So if you would like to do that, check that out. That is in his GitHub. And a shout out for our community Slack that we have. It's a really great place to come and ask questions about vCluster. The maintainers are all there. I'm there, a bunch of users. One thing that we've started to see, like in the last 9 months or so, that's been super encouraging is more users answering other users' questions, which is super cool. There is also, I should mention, a vCluster channel in the main Kubernetes Slack. So we added that just, I think, a couple months ago. If you are in the Kubernetes Slack and you look, you'll see a vCluster channel in there. You're certainly welcome to ask questions there. The thing about it is it's a lot newer, and so there just aren't as many people in there. And so the maintainers are there, I'm there, a few other people, but there are a lot more users in the community Slack who can potentially help you. So I just want to thank everyone. Oleg from our engineering team gave some really great feedback when we were starting to build this talk out. I really appreciate that. The other vCluster maintainers and contributors, and that includes people who opened issues or anything like that. One of the things that's been really great for us is the amount of feedback that we've gotten from people, and we really do try to listen and implement things. Thank you to the organizers of the meetup. I have been a meetup organizer before, and it is hard work. So thanks so much for having us, and thank all of you for watching. And that is it for the presentation proper, and we are down to answer some questions if Joe has any to pass on.
Yeah, I think, thank you, Carl. You've done a great job of keeping up with some of the Q&As while Rich has been talking. So as of right now, I don't think we have any questions. Folks, if you do have questions for Rich or Carl, please use the Q&A feature of the Zoom webinar, or reach out later through the Meetup or GitHub or Tech 404 or Kubernetes Slack, and I'll make sure to get them to Rich and Carl to get some answers for you. And I'll try to sync with Rich and Carl to get the deck, so you have the links and everything as well. So
perfect.
Still no questions popping up. So
Ross has a hand up.
Oh yeah, Ross,
I have a question. I can't ask it in the Q&A thing, I guess, because I'm a panelist. They want me to ask it in person. So what kind of use cases have you seen for custom plugins? Maybe not ones that have been open source, but even internal customers. What are they using those for?
Yeah, sure. So I think the example plugins that we have are kind of the starting point for where this all kind of came from. So we sync Ingress, great, that's good. But I want to be able to sync cert issuer stuff or cert manager things. That's kind of the obvious stuff, just things that are not pre-canned, but kind of prevalent like that. And we mentioned, we didn't kind of demo it, but the future of this is hopefully the generic CRD syncer, where we don't necessarily have to have a dedicated plugin for everything. We can just define in a regular YAML blob, these are the things I want to sync. And that kind of lowers the barrier of entry too, because right now you got to write Go, you got to, blah, blah, blah. There's some stuff to do, and it's, as an operator, you maybe aren't doing Go development, or there's a developer, you're maybe not up to speed with all of the cert issuer things and whatever. So hopefully kind of striking a balance in the middle there. I don't know if that answers the question, but hopefully the right idea at least.
Yeah, I mean, I think that it's pretty much always been, there's something in the host cluster that I want to share in the virtual cluster,
Cool.
That's usually the scenario, I think.
No, I mean, that's awesome. So we're looking at vCluster quite a bit right now, actually, starting to explore it. So this was very, very helpful.
I should have been more professional then. It's just smoking and BS everywhere,
I was yeah, I don't know. They're liars. I'm not sure if I want to use this anymore. So
you know me, Ross. You know me.
No, not liars at all. Not liars at all. The other question I have is, there was one other thing. Sorry, it's slipping my mind now. I'll remember it. I'll ask you later. But okay. I have many questions.
Yeah, awesome. We've been seeing more and more people who are, looking at vCluster for lots of different things. Some of the big use cases that we tend to see a lot, dev environments is a really big one. I think that CI/CD is a fantastic use case for it. If you've worked with test suites, a lot of times these test suites can be very long, and if depending on how they're designed, one pattern people like to use is being able to just throw everything away at a certain point, right, and start scratch with fresh data and a fresh environment. And if you're using one of the cloud providers managed Kubernetes, it may take you 15 minutes to get a new cluster, and that's all adding time to your test suite. And so being able to do that in a few seconds instead is really huge. And then yeah, I mean, I think that those are honestly the biggest, the biggest ones that we see. But then again, as I mentioned, we're also seeing this thing starting to happen now where people are starting to use it in other tools, which is really exciting. CodeFresh added a feature where I think it's on their free accounts where you can get a environment for your PR, and those run in vClusters. It's they're using that to help save costs, and so it's been really exciting to see like all the different things that people are doing with it.
I think those are all the use cases that we're looking at too. One, I remember the one that I had is you can support HA now. So have you started to see things like people running like almost like chaos tests inside of vCluster or something like that?
I have not heard of that happening. Have you, Carl?
I don't know about chaos, but there's definitely people that are doing like real like production things, which I know is something we kind of, I guess you associate vCluster with, development or whatever, but like there's real HA clusters doing real production workloads and stuff. So I assume that's part of I know for a fact that there's tons of people that are doing like full-blown testing with vClusters and then promoting to prod. So I gotta assume there's people doing some crazy things.
I mean, I'm not aware of anything specific.
Yeah.
Like I haven't heard a story about that, but I wouldn't be surprised. It's funny that you mentioned this because I literally was just thinking about this like last week, because I used to work for a company that offers a chaos engineering SaaS. And I was thinking about how that might fit in with vClusters. So yeah, you kind of read my mind there, Ross.
Cool. Oh, thank you all so much. This is really cool. I appreciate it.
Yeah. I think Carl's wrapping up the one last question from chat. So huge thanks, Rich and Carl. Great content. Thanks so much for coming out and sharing that with our community. As always, we have another great set of speakers coming right up at you now. And I might be a little bit biased on this because these are folks from my team at Twilio. So I'll stop talking and turn it over to Sean Shin and Ross Edmond. The probably my favorite talk title in a while, but Rego my Eggo in living policy. Let's have it, guys.
All right. Yeah, I got to give credit to Sean on this one. Rego my Eggo, pretty amazing title. Anyways, I'm Ross Edmond. I'm an engineer at Twilio, and I'm helping build their next gen platform. Sean, do you want to introduce yourself?
Yeah. My name is Sean Shin. Pretty much same thing as Ross said, just a software engineer, just doing some stuff.
So today we're going to talk about policy and our journey adopting Rego and kind of what we went through. So let's talk about policy. We're going to use the word policy a lot, and when we talk about policy, it's very similar to how we say like the network or the cluster or something like that, where it all of the things that encompass policy are what we mean when we say policy. So the different software components, the distribution methods, all of those things, you'll hear us like refer to the holistic solution as policy. I just wanted to define that before we start talking about it. Let's see here. Am I missing slides? Maybe. Okay. Let's do this. Okay, so Twilio has set out on a journey to build a new platform. Sean and I's mission is to help build like a new modern application platform, as well as to design for reliability and security, and most of all to build trust. I think this is one of our personal goals, is like, how do we start to build a platform that has trust built into it? So compliance, security, reliability, all of these things that we like to talk about and push into our platforms and away from our engineers, so they have like less cognitive load. The biggest challenges that we face is compliance is really hard. I think most of us know this. This is not something that's unique to Twilio. If you've ever had to go through any type of security audits, it takes a long time. It takes a lot of effort. People have to pull a lot of proof for things. And so this is a huge challenge. It's something that Twilio currently struggles with. Like, we have to meet a lot of different compliance regimes. So lowering the effort it takes to do that is one of our missions in this platform. We have a modern stack. A lot of the stuff that we're building is all cloud native. And so we also need controls at every layer to secure that stack. That includes, cloud, compute, cluster, pod, all the way up. And that's really complicated as well. Like, we find that security teams are struggling with how complicated distributed systems are and where they can inject themselves to secure the organization and lower risk. And so we believe that something as platform engineers is that we should be helping address this. And then most importantly, as well, as like shifting left. We believe that if we give developers the proper resources early on, that they would fix the problems with security, compliance, reliability, and they would do it and move on. And it would be much cheaper because cost of change would be so much lower. So when we set out on this journey, we wanted to have some guiding principles for like helping us select our solutions. One is portable. Like, we need something that's portable. We found that most compliance tools are not portable. They're something that you usually have to lock into the whole suite of tools top down. I think a good example, I love HashiCorp, but Sentinel is a great example. Can only be used with HashiCorp stuff for the most part, which is really limiting unless you're like completely on that stack. Second guiding principle is self-service. We really want engineers to be able to unblock themselves. Once an organization reaches like a critical mass, you just start to run into these roadblocks as engineers where you have to talk to so many people to get work done. And removing that barrier allows people to just ship faster. So our goal is to allow engineers to do that, especially with in regards to security and compliance. And then most importantly, operational patterns. So Sean and I have kind of like racked our brain on this for a while, and we think that policy should be treated just like an application. So you're going to hear us talk about policy in a similar way, where we think that policy needs to be built, tested, validated, distributed, deployed, and then observed in the same way that an application is. So we're using those principles as we like designed this solution for Twilio. And we're going to dive into a lot of this solution. So, and then I have this really inspirational quote: audit findings are easy to come up with. Successful change from a finding is true internal audit value. I searched for audit quotes and it was a bunch of CFPs, and I have no idea who they are. And this guy's name was Michael Piazza, and he is not the famous baseball player, but I really like the sentiment of the quote. I think what we're really after is how can we build a process and levers into like how we deliver applications where we can change engineers' habits over time. And so we set out to do this with policy. And as we like looked at policy and all the places that we wanted to inject policy in our stack, we realized that there's really three classifications of policy that we're interested in. One is build time. So what happens in CI, testing, as close as we can get to the engineer so we can give them feedback. Deploy time is like the big one. This is like, I go to deploy the thing on the Kubernetes cluster and I deny it because it has some sort of like risk factor that we don't want to accept. And then we have runtime policy, which is like communication level policy. Like, I want to talk to this service and make this type of request. Can you authorize me to do that? Do I have the rights to do that? Twilio is currently writing policy for all three of these types of layers. Sean and I really are only focused on build time and deploy time because another team is doing runtime. And so we're going to mainly be talking about that. But the tools that we've selected for each of these areas really all fall into the open policy agent ecosystem. And so we're going to be spending a lot of time talking about that and how we glued these tools together to come to a solution that like is really helping our developers. You'll see constraint talked about throughout this presentation. Constraint is kind of our glue, and we will show you some more of what that is. It's not something that we built, it's something that we found in the open source community, and it's become like a linchpin of how we do policy. So we're really excited about that. Let's see. Yeah, so we built a policy distribution process, and we believe treating policy lifecycle should be just like applications. And we are going to walk through what that looks like on our new platform now. So here's just like a quick diagram of how we see this working. Is at build time, we have some custom OCI tooling that it's kind of been built on top of like the Carvel suite as well as Helm and some other tools. But we've kind of like made our own process for doing that. You'll see that come up a little bit. It's called bundle cuddle. And then we're using Comtest. Comtest is part of the open policy agent ecosystem. And we're using that to run tests, do formatting, check validation. It's really like our unit testing suite. And then we use constraint. So constraint is a tool that takes Rego and generates gatekeeper constraints from it. And we will talk about that some more as well, if you're not familiar with the ecosystem. And then as we go through like the build process, we deliver these policies into like an actual bundled OCI artifact. And once that's bundled and shipped, then we can deploy it out to all of our clusters, and we can observe it actually being applied and see where there's violations and how we can remediate them. So first quick demo is we're going to talk about bundles. We talk about bundles a lot. Bundles is something that is kind of internal to Twilio, but it shows up other places. So like Open Policy Agent has a very similar concept of bundles that we do. But what is a bundle? So a bundle is a packaging concept that is based on OCI standards, and it allows us to ship a point-in-time snapshot of configuration. So the types of things that we put in here are Helm charts, we put Rego policies, we put static config. So far, I think that's it. The idea is that the outside of the artifact meets the interface, so we can do a lot of things with it. The inside of the artifact can have a lot of different types of stuff in it, whether it's policy or platform features or anything else. So we're going to be focusing on just like what a policy bundle is, but in general, it's not as intimidating as it sounds. It's a bunch of files inside of a tar ball, basically. It's a really cool zip file, right? But overall, we selected OCI because it's open standards. We believe that we can take it and ship it anywhere. It adheres to Docker Registry v2 API. And then long-term, we really want to get to signing and verifying all of these artifacts. So when we create a new policy bundle, we also want to be able to attest that it's ours and that it was shipped on a certain date and that it was, built with certain criteria and met all of our standards when we shipped it. So that being said, let's look at a policy bundle. The TLDRs, it's got some files in it. So I'm going to reshare my screen here. This cool terminal. And I have a local cluster running. It's not in vcluster, but I'm very jealous because mine took a lot longer to start up. So we use the Carvel suite quite a bit. We abstract a lot of it away from our engineers. So we have the cap controller. It's very similar to Flux or something along those lines where we can do kind of like a GitOps process to get things in cluster. One of the benefits that you'll see with CAP is you can declare packages and package installs similar to how you would like an apt repo or something like that. Okay, so I have a cluster running, and I will show you what a bundle looks like. So this is a bundle structure. There's really not much to it. These are just the directories, but overall we have kind of a directory structure that we prefer. Honestly, like if you wanted to build something like this, it could be whatever you prefer. But in our policy bundles, we have some folders directly for policy. We usually ship a core library, and then we put our policy in there. And so if I dump this out, you can see that we have core library, some tests, and then we actually have a policy. And I'll show you what that policy looks like. If you are not familiar with Rego, Sean and I were not familiar with Rego or any of this recently, so we are not masters of this. We do not know everything about it, but it is something that we've really enjoyed learning about. And so this is a very, very, very simple policy. And what it's saying is, if you have this annotation, you shall not pass, then you've caused a violation and we will send you a message. So it's our Gandalf policy. And then we'll probably cover some of this later, but we have a lot of metadata here. This is part of the Open Policy Agent format. This allows us to version our documentation along with our policy, as well as inject our custom policy IDs. And then we have these matchers here. We'll talk about what this does when used with constraint, but overall, the source of truth for our policy lives in the Rego file. That's the key part of this. So I'm going to, let's see, I'm going to build a bundle. So I have a local cluster and a local registry, and we're using some of our tooling to build this bundle, package it up, push it up. Normal Docker registry. If I think that fast enough. It is not going to show me anything. Of course not. Because is it actually running? It is. Okay. It doesn't want to show this to me. That's okay. I'm going to skip this for now and just show you the files. So what really happens is it builds OCI artifact, it puts it in the registry, and then you can pull it down and unpack it. And when you unpack it, it's going to open up this temp directories from a previous run I did of this. And inside of our bundle, you will see our policy and all the things that we just talked about. And then there's some special magic that happens. In this templates folder, we'll see some constraints. One of the biggest challenges we found with the Open Policy Agent community is Gatekeeper and Comp Test and some of these tools aren't very aligned. A lot of them accept Rego. Gatekeeper has its own special format called constraints. And managing all of those is really complicated. To meet our goal of having something portable, this was one of the problems that we needed to solve. And so when we build a policy bundle, it generates a constraint, it generates your CRD, and then it generates your constraint template. And you'll notice that in this template, here's the policy we just went over. So it takes all of the Rego and it injects it in. It finds everything that the policy itself relies on, and injects that in. And now all of a sudden, we have this tarball or zip or whatever that has some metadata, it's got some Rego files, and it's got some constraints. And that allows us to be able to pass it to CI or to different clusters. That is a general overview of what a bundle is. And so I'm actually going to pass it to Sean, and Sean's going to show how we've taken this process and used it to scale out so we can ship a lot of policy. So Sean, I'm going to hand it to you.
Yep, sounds good. Let me just share my screen real quick. Okay. So yeah, as Ross mentioned, I'm just going to be kind of covering the policies during build time and exactly kind of how we've put it together. High overview, just quickly, of like the architecture. We have a monorepo setup currently, which is housing all of our specific policies. And the team's chosen to leverage BuildKite as our build system. And pretty much what happens is whenever a new policy or a change is detected in this repo, our pipelines will dynamically just kind of kick off and figure out what exactly it is that needs to be built, pulls in the proper BuildKite plugins that we're leveraging, like Ross had mentioned, our OCI custom packaging tool, and then also our contest BuildKite plugin that we just built set up to abstract away a few some complexity from the rest of the Builder engineers. And basically, once all of this runs, as Ross was mentioning, we will have the ability to generate constraints, which are those gatekeeper resources, as well as run unit tests and also do some format checking even before to make sure the builds are passing in conformant. And then if that happens, we'll push it into our ECR or artifact store registry for when it can actually be used for later. Okay. Move on. So I'm gonna just follow this link. These are, our private GitHub repos. So it's all good for now. But for example, as Ross had shown, just a quick structure of the PR. So we have all of our file structure as you had seen. But also, if we just kind of crack it open and look at the details, we can move over to the actual BuildKite job. So as we see here, here's kind of some logic that's being kicked off. We'll see it's like generating our constraints, whatever else we need, running unit tests. As you can see, these are actually all passing and whatnot. And then we actually build the bundle and show people, hey, this build is indeed, it's made it into our policy or into our registry and it's ready to be tested and all of that. Cool. So now I'm going to jump over to another one. It's just an example of a failing deployment. So this is within our other repository, which we handle kind of our store all of our YAML files for our deployments and so on and such for cluster deployments and whatnot. And if I actually crack open this commit real quick, I'll just go to files, sorry. Okay, so you'll see here, you notice that we have this annotation, you shall not pass, which was very, very similar to, or it's just exactly the same as what is going to be a violation. In our BuildKite test, you'll see that we actually have some failures. And if I open up the results, this is telling us exactly what is actually happening. And we follow this nice little link here. As part of our process, with all that metadata Ross had kind of shown you earlier, we have the ability to also generate our READMEs specific to our internal document site. So we can point developers and engineers to the right place to actually fix their violations. So let's say, for example, now we go back over to this passing deployment. I have fixed my annotation by changing it from you shall not pass to you shall pass. And if we look at sandbox, we're all green and we're good. So that's my section. I'll move it over to Ross to show you how this same policy can then be applied within clusters to actually deny this very feature that we are also not wanting.
Yeah, so going back to treating policy like application, like this is a workflow that we're all really used to. You make a commit, it kicks off a build, it gives you a bunch of feedback. If you pass, it ships the artifact, so you can then deploy it. And so right now this is full of Rego policies and it's full of constraints. So once we start to ship a policy, how do we roll it out to clusters? You saw in Sean's PR, he's updating the policy and allowing like that to roll out in CI. So we kind of like escalate to CI. And then once we start getting violations there, we start correcting them. And then once those violations get corrected, we start to roll out to our clusters. So then you can't go around CI basically. And we get like a full rollout. It's like a way for us to kind of like turn that tap on and off. Like, hey, we have some violations. Let's start to warn. Let's start to stop it in CI. Then let's start to stop it at the cluster level. And so what this ends up looking like is whenever we build a bundle, we also build the documentation, which Sean showed you, and that ships to our like internal platform documentation. So when we roll out a policy bundle, it has corresponding docs. It has a link that can send you to the docs in the error message. And then we like roll it out cluster by cluster. And so I'm going to show you what our rollout process looks like. And we'll talk about some Carvel stuff a little bit. So one of the things that we use is we use the Carvel toolset with the cap controller. This is a package declaration. This is not the same as a package install. It just like tells the cluster that your package now exists. So we kicked off the CI process, the bundle was built and put into our registry, and we've now declared it inside of our management cluster, which I will talk about. So we are running Cluster API. We have a management cluster that kind of hosts all of our packages, and we can use the management cluster to push those packages out to workload clusters. And we do the exact same with policy. So it's a way for us to have like a choke point where we can say, I want the you shall not pass policy everywhere in my environment. And so we've declared this package. We know that it exists. We have a couple of different versions even. And then we want to apply it to a cluster. So in this case, I'm telling the management cluster, I'll show you what this package install looks like. So we declared the package, and now we're declaring a package install, which is the instantiation of that package. And we're going to deploy that package to a targeted cluster. So I'm going to apply it. Jump into my management cluster. We can see reconcile succeeded, which means our policies have been rolled out to our cluster. I'm going to jump to this cluster. Oops, I was going to jump to that cluster. And then I exited. Oh. Try again. So we should see a constraint here, the you shall not pass constraint got deployed. Oops. Hey, we can see 0 violations. We've deployed our policy. If I do a describe on this, it reports all the different things that it's audited. There are no violations right now. That's great. Fantastic. Let's try to deploy something. So I have this deployment, Balrog, the fire demon. He has an annotation that he shall not pass. Hopefully our policy deployment worked. Let's see. So I'm a developer. I'm trying to go around the CI pipeline that Sean just showed. I think it's garbage that you said that I should not be able to pass in CI. I try to go directly to the cluster. It tells me the same thing. So I can click on this and all of a sudden I'm back where I started in CI. Hey, you got to go fix your stuff, right? Pretty cool. So I've successfully blocked this attempt. I'm actually going to remove my, oops. I'm going to actually uninstall the constraint as a really bad developer. Let's see, I'll do this. I'll uninstall it. This is going to remove it from the cluster. I'm the worst developer in history. I'm now going to apply my thing. Into my workload cluster. And it's going to work, right? Yes, it's going to work because I subverted the system. And now I have my deployment. Okay, that's cool. So I managed to break this. So let me output this, make sure it's there. It is there. I have a you shall not pass annotation. Great, I'm home free. Here comes my GitOps syncing process again. It's going to reinstall the package YAML that I tried to subvert and roll the policy back out. All of a sudden, let's see if it's happened yet. Kind of takes a second. Oh, we have a you shall not pass. The policy's rolled back out. Let's check again, see if it's run yet. Hasn't. We're waiting for violations to show up as it scans our cluster. Still not. There's not that many things on the cluster. You can do it, Gatekeeper. I believe in you. Wow. Unless it stopped it. Not yet. All right, let's go check it out. Let's see. You shall not pass. What's going on? No luck yet. No violations. I don't believe this. Waiting, waiting, waiting. Annotations. Oops, need to deploy annotation. We still have a you shall not pass. Let's see if it's audited it yet. I believe in it. Hey, total violation 1. We did it. So our app is still running, but now all of a sudden it's reporting this violation. I think it's pretty interesting. So we've created these dashboards that start to surface these violations. All of a sudden, now our infrastructure engineers are like, hey, wait a second. What is happening? Like, why is this triggering, right? If I click here, it should take us back to the policy documentation. Once again, we feel like we've managed to subvert the system, but now somebody has caught us and they will now probably revoke our credentials and delete our stuff. And so let's delete it. The policy is still running. We'll try to deploy it one more time. Hopefully this time we will be blocked and all of our attempts have failed. We're back to our policy documentation. We do have one successful deployment that we can run. This one has a different annotation of you shall pass. Let's see. Oh, oops. Oh, passing, not success, passing. All right, and if we get to deploy, we see Frodo shall pass. You shall pass, Frodo. Frodo was able to deploy, our Balrog was not. Yeah, so we believe that through this process, I want to go back to our goals. So we believe that this is portable. We didn't show local development, but we can use this locally. We use it with Git hooks. If you use Git hooks, we don't force people to do that. We're not monsters. We believe it's self-service. As you saw, you basically get told to go to the documentation anytime that you try to do anything wrong. We have operational patterns. We're able to roll this out. We're able to version it. We're able to sign it. We can roll back. We can observe it. All of those things. We did this with very little amount of work. It's kind of a few bash scripts, to be quite honest. But the technical thoughts that we have is we use CompTest, Constraint, Gatekeeper, and Rego to build this process. Rego is the source of truth for everything. We treat it as the source of truth. The policy document is kind of like our guiding light. All the documentation is generated from that document. The gatekeeper constraints are generated from that document, with the outcome being these should always be aligned. We shouldn't have security engineers having to go update documentation. You shouldn't be looking at policy documentation that's 6 months old or out of date. That just causes more confusion. Constraint really became the glue that binds this together. It helps us move the policy across the boundaries of build time and deploy time. And most of what we've done, we actually stole from the constraint repo directly, copy pasted it right in, and kind of built the distribution process around it. So if you think this is really cool, we didn't build most of it. Go check out Constraint. Go check out some of these communities. There's a lot of really helpful people in here doing creative things. And we found this project incredibly interesting and valuable. And we hope that you did too. And that if you have questions, we will take as many questions as you want to ask us. Yeah, that's it.
I have the ability to see this stuff every day, and it still puts a smile on my face every time I see this. It's just awesome. Thanks so much, Ross and Sean, for sharing that with our Kubernetes Atlanta community. Folks, if you have questions, feel free to post in the Q&A feature of the webinar or in chat. And as always, if you can't think of one right now, feel free to reach out to the meetup later, and I'll get your questions in the hands of Ross and Sean and get you some answers back. Give a few more seconds here for questions, see if they roll in.
No one asked the question, but yes, it's about 150 lines of bash. Thank you. No more questions.
I've done my part.
It will not shell check, but we do have some shell check on our bash scripts for this. So yes, we pre-shell check the thing that does the policy generation.
And Ross put a little turtle emoji in the build kite message for the shell check.
Yes, the most important feature that I shipped was the build kite emoji for sure.
I saw some party parrots in there, and I thought that made it very legit.
There's so much very useful and personal information embedded into our CI, like signaling from emojis. Like it's choice. I don't even read the words anymore. I just watch the emojis and I know exactly what's going on.
Does that management cluster become like a single point of failure then? Is that a concern?
So actually, we've kind of started to reverse that pattern. Joe is actually working on that quite a bit. And we have another member here in the chat, David Bloom, who's working on that. So it does, but we found that like it's so infrequent that it needs to run all those updates that if we can move, like right now we have Argo CD on our management cluster. If we can move that off, our SLA for our management cluster actually becomes really low because it doesn't have to sync that often. And if it's down, it doesn't really cause any problems. We're not like really running anything else through it. Yeah, so overall, I think like we have some concerns there, but doesn't seem as bad as it might appear.
Yeah, it'd be more like more impacting new stuff getting pushed out. Is that?
Yeah.
Yeah, and overall, like, because we made some really nice choices to kind of treat everything we deployed our clusters, like from a platform perspective, like around that OCI interface, it gives us some really cool stuff to like move from this current like push model from the management cluster to just move to a pull model where each cluster sort of self-resolves what it needs on itself.
Nice.
And so eventually that'll kind of take care of that problem, and the management cluster will just be for, you know, creating new clusters and, you know, keeping doing the cluster API stuff basically.
Nice.
One of the really awesome use cases we found with this policy solution is the example we showed is really trivial. But because we're using cluster API and we're declaring all of our clusters statically, we can run tons of policy checks against our clusters. So like we just shipped a policy, like if you try to create a new cluster and submit it to the management cluster, it'll check n number of things. One of the things it's going to check is, are all of your instance types in your, we use AWS, so are all of your instance types in your mixed instance policy Nitro based, because Nitro instances have encryption between each other. And so that allows us to like check a huge box. And so every time we create a cluster, we get that feedback in CI, and then we get it when we deploy it too. And so we're seeing these really powerful features be able to like be used, especially with CRDs, and especially around like infrastructure creation. We're kind of being able to do like normal policy things, like you can't do host networking, you can't do IPC, like you can't do that kind of stuff. But also we can say, does your cluster have the right side ranges for access, or, you know, those kinds of things. So yeah, really powerful, really awesome. The management cluster becomes very interesting combined with policy.
Auditors must eat that stuff up, man. Well, you can
They're
just show
gonna
them
love
that,
us.
like, yeah.
Our honestly, like our goal is to start generating reports, like audit reports. I think long-term would be our goal is like, here's a SOX report, here's a, you know, HIPAA report, and then having auditors be able to access this like live audit information where we can say, we know that this policy has been enforced for this amount of time because of this observability aspect. So
yeah.
Another neat thing I kind of wanted to touch on too. So conftest in Rego, like that language is super flexible. So this is the policies we wrote and showed off were specific to YAML, but they can be adapted to be used for like Terraform, HCL, or JSON, and a whole bunch of other things as well.
Super
Awesome.
cool.
Huge thanks again, Ross and Sean. That's basically it for the meetup this time. Have a little bit of outgoing housekeeping. Remember that we do have some social time after this, so please stick around. As always, put a call out there for speakers. If you're in our local Atlanta community, or if you're anywhere else in the world, feel free. If you got a topic that's near and dear to your heart, please come share it with us. Just reach out to us, K8satl@gmail.com, GitHub, Tech404, Kubernetes, Slack, you know, a bazillion other different ways to get in touch with us. If you have a specific topic that you'd like to hear about, reach out and let us know, and we'll track down and try to find some speakers for it as well. That being said, thanks everybody for coming. Thanks to Calendly again for sponsoring the Zoom for the meetup. And again, stick around. We'll convert everybody over from attendees to panelists, so you can turn on your cameras and your mics, and we can hang out and chat.